Hey everybody, welcome back. Today we're doing another upgrade video, this time on a little speaker from Celestion. This is an SL6 and this is the signature version. Now we've had somebody send us one of these in the past that wasn't the signature version, and we wound up designing an upgrade for it, but I never did a video on it, never released it because the tweeter that was in that thing was unusable. And so we wound up finding a tweeter that we had in stock that was a dome tweeter that fit this exact same bolt pattern, and we screwed a new tweeter on from the back side and was able to design a much better response, or get a much better response out of it. That tweeter, in fact, I'll dig up an old frequency response of the original tweeter and show you what it looked like here and get Ron to throw it into the video here. It had a huge rising response as you went low, and then there was an enormous amount of ringing at the top that you could see in the spectral decay that just went on and on. It was horrible. In this case, this one had a similar curve, but it wasn't near as bad. In fact, let's look at the new, the raw driver here, just the tweeter's response, and you can see it's not as bad. So I was able to work with this one and try and figure out something with it. Just like you'd expect from a lot of speakers at this price point, lightly constructed, cheaply made. These are the parts in the crossover, and even the crossover is not even on a copper circuit. It's just traces, just like solder traces, tin traces. Iron core slug on the woofer, poor thing. A tiny little air core on the tweeter, which is not bad. And these caps are either polyester film or polycaps, polypropylene, I don't know. They've sheathed them in shrink wrap or heat shrink, and then of course a sandcast resistor. Binding posts were horrible too. Nice little polycone, fairly well behaved, but it did have one big old hump in the response down low that obviously needed some attention. Let's look at the frequency response on this thing. Let's look at the factory measurements, and also this thing was voiced down quite a bit. The whole tweeter level was just much lower than the woofer level. Yeah, let's look at the frequency response. You can see down low how much extra energy there was there, and you can see that big hump I'm talking about in the woofer's response. It's right there around 500 or 600 hertz. We tried it with the grill, and you can see with the grill that the grill didn't really have a bad negative effect, but it didn't really help anything either. Vertical off-axis on this thing was rather good. If you moved up and down, it maintained a good phase response. And the horizontal off-axis looked okay. Little heavier in that 3K to 4 or 5K hertz region there as you move off-axis, but not bad at all. Impedance curve, nothing crazy going on there. You can see it's a sealed box, and it only dropped to 5.2 ohms. Spectral decay is not too bad either. There is some ringing going on right there near the crossover point, which is fairly high. So a little bit of excessive ring going on, but overall, the main problem is this thing is just voiced poorly. The tweeter level is 2.5 dB to 2 dB down from the woofer level, and the parts quality is sucking the life out of the signal. So first thing I do is I gut this thing and I hook some new wiring to the tweeter in the woofer, and I just run it right out the holes in the back where the ports, or where the binding posts were, sorry. And then I start looking at the frequency response and dropping values on there that I know is going to correct it. Like I'll put a coil on the woofer circuit and get it to drop over, kind of see what it's doing, and then maybe put a cap in shunt with it and try to drop it down like I need it to, and then address a big hump. I'll look at it and think, okay, I need values for a notch filter right there, and I'll grab a coil and a cap and put it on it, and with no resistor, and just see where I create a hole. Like, did I mirror the hole, or was I off a little bit? And I think this time I was off a little. I just kind of know in my head what values it'll take to notch at that frequency. And then sometimes I start juggling the values back and forth to make it more of a wide band notch that I'm pulling down, or a narrow band notch that I'm pulling down, depending on what it's looking like. And then once I kind of nail that frequency response, I'll start putting resistor values in line with it to see how much it takes to pull it down. What does it take to make a nice flat response? That's what I was having to do in this one. In fact, let's look at the woofer's raw response, and you can see what I'm talking about. You can see that big peak in the woofer's response. Let's see, 500 to 700, peaking hard at 600, it looks like. That needed the notch filter. And then if you look at the driver overlay, you can see that it's still going to be tough to get the woofer level down to where it meets the tweeter. The tweeter's level up top is down quite a bit, so that's what I had to work with on this thing. So let's look at what I came up with on here. Let's look at the new crossover overlay here, the crossover response. You can see it crossed at around 1900 hertz, and I was able to get a nice flat response out of it. You know, a lot of that had to do with the fact that I had to put that notch filter back there on the woofer, and that did cause the impedance to drop a little bit because there's a little bit of an aggressive filter there. But I think overall it's still within a 4 ohm range down there where that notch filter is. So still usable. Looking at just now the new frequency response, you can see it's plus or minus less than a half a dB all the way across until you get up to the top of the tweeter's range where the tweeter just has a hole in the response. There's no bringing that up. And there's a ringing going on still at above or at 20 kHz or so, peaking at around 22, 23 kHz. Pretty stout right there. Horizontal off axis now looks a lot like it did, but it's more balanced where it starts dropping off. Vertical off axis looks similar, but we're seeing a little bit of dropout now as you get really high up. But I had to kind of keep those values there in order to keep them in phase up there at that crossover point. Impedance curve, like I said, let's look at it. It does drop a little low to 3.1 ohms right there where that notch filter is, but it's up there at a frequency range where it's not going to draw too much current. So it's kind of the same as any 4 ohm speaker. And then spectral decay looks fairly clean. Nothing to get super excited about. You can see that ringing way up there at the very top. There's a few areas there through the middle of the range there that's got a little bit of ringing, but not bad. Not anything crazy. Overall looks pretty good. So we're just going to put together a little upgrade package for it, as you'd expect, just like we do with a lot of other things. New coils, new caps, new resistors, set of tube connectors. An easy project if you own one of these things and you want to get your feet wet doing a little DIY. This would be a good one to start with. It'll be an inexpensive upgrade and something you can have fun with. The results are going to be significant. Bringing that tweeter level up to where it bounces to the woofer level is going to be like bringing the resolution up on this thing by a lot. So that's it for this one. A simple little upgrade. That's how we do it. And I appreciate you guys watching. See you guys in the next video.